Hi there. Today we're diving into skills in the AI world and how to use them with the Agent Development Kit. Let's start with the definition. In simple terms, it's just a piece of a prompt that isn't available to the agent from the very beginning. The agent can discover and use skills during its work. What's also important, skills can contain tools or runnable pieces of code. Be aware that there may be different implementations of skills. However, their most popular current version has a fairly well-organized structure. A skill must always include metadata, such as name, description, and often additional data. The most crucial part of any skill is the knowledge. Typically, this comes in the form of a file that outlines a certain procedure. But it can also include a lot more, like additional reference files, scripts in different programming languages, or extra resources such as documentation or images that complement the main procedure. Metadata plays a crucial role because it enables discoverability. As I mentioned earlier, the agent doesn't have this knowledge right from the start to conserve context and reduce costs. However, at any moment, it can choose to acquire more knowledge in the form of a skill. So you can think of skills as a layered construct. In the first layer, we have only the name and description, so as not to overload the context. The second layer is the main procedure, which the agent can load at any time. And the remaining elements make up the third layer and can be added at any time based on the procedure. When it comes to technical implementation, the first two layers are usually found in the SKILL.md file, while the rest make up the directory and file structure on the disk. But that's enough theory for now. I think things will become clearer once we dive into the practice. This is the skill in the simplest possible version, meaning just the skill.md file. The header contains only the name and description. The three dashes separate the header from the main content. Note that the main content is formatted as a markdown document, which is quite a popular format in the AI world. However, the header itself is written in a strict YAML-like format. The name and description are the minimal set required for discoverability. However, the header can be extended with additional information such as license, author, version, and more. I will come back to this later because it will be needed. For now, the main takeaway is that the file skill.md has a clear division between the header, which the agent uses to decide if it needs the full content, and the rest of the document. Before I move on to the Agent Development Kit framework, I'll first show you how the skill works in practice using Antigravity-CLI. This is important because I want to show you that the skills are reusable. I'll use the same skill to create my ADK agent. You probably know the Antigravity-CLI. I'm entering a prompt now. I'm asking the agent to check the outside temperature and turn on the air conditioning if it's warm. You need to admit that this is a real-life case, isn't it? Antigravity has already accessed the SmartHome skill from my disk. Plus, it's also reviewing additional files related to that skill. Now it's asking me for permission to run a script to retrieve the temperatures. The next request is to execute a script to set the cooling to 20 degrees. The air conditioning was set to 20 degrees, and that's exactly what happened in reality. This API actually works, and it's scorching hot outside. This is the skill.md file belonging to the SmartHome skill. Here you can see the standard location of the skills files used by Antigravity. Take a look at the header. This is what lets Antigravity know that the SmartHome skill should be used. The main content is also more detailed than before, and it's intentionally broken down into layers. This way, you have extra references. The API.md file in the assets directory is the documentation for the API used in my SmartHome. To call the API methods, Antigravity uses a script written in Bash. As you can see, API.md is simply a description of the API methods that are available in my SmartHome. The Bash script takes an endpoint as a parameter and calls the API. Nothing complicated. Obviously, you might question if it's worth simplifying this setup a bit to avoid reading too many files, but its complexity is actually helpful here because it lets us explore a variety of agent skills. Let's finally move on to ADK. I'll be working in the virtual environment that you already know, so if you haven't watched the previous episodes, you can find more information about it there. I'm creating a new agent from a template. As always, I choose the second option because I will be using Gemini 3.5 Flash. As part of the preparations, I am also copying the entire skill directory from Antigravity. Let's see what's in the directory. This is exactly the SmartHome skill that I was just using in Antigravity. The foundation for further work is therefore prepared. I can now proceed to creating the agent's code so that it uses this skill. Here's the agent template you're already familiar with. First, I'm entering the name of the model I'll be using, which is Gemini 3.5 Flash. Just like always, I need to provide a description and instructions. Since I'm developing an agent for managing a smart home, that's the information I input into the configuration fields. This prompt is somewhat simplified, but the main part of the knowledge will come from the skills, so I don't really need to add anything sophisticated here. This isn't any different from the agents I prepared in earlier episodes, but let's introduce changes. I'm just adding some imports because I'll be using a few new functionalities. In the first part, I will use skills loaded from the disk. I'll also need something called a skill toolset. In a moment, you'll see why. The pathlib is needed to construct paths. Now I'm defining a smart home skill based on what I have on the disk. Load skill from dir allows loading the contents of a directory as a skill. Of course, the file structure must be as we discussed earlier. Let's take a moment to discuss the concept of the skill toolset. As I said, all the skills should be discoverable. In ADK, this is implemented by creating a special set of tools that allows listing and loading individual skills into the agent's context. So I define my skill toolset, which is an array of tools, and it is created from the array of all skills that I want to make discoverable based on this skill toolset. In my case, there is only one skill, so the array of skills has a single element, which is Smart Home skill. When you see the tools in action, I promise it'll make more sense. What's important to remember is that the skill toolset is used across all defined skills. I still need to include the toolset in the agent configuration. Just a quick note. If you haven't seen the episode about tools yet, the information from it will be really helpful for today. And that's almost everything the agent with skills needs to work. In fact, there's one thing missing that will prevent the agent from working in this specific case. But I want to demonstrate this in practice so you can understand why. Let me go ahead and start the agent, and then we can move on to testing it. As always, I start the ADK web, because this option allows me to perfectly monitor the agent's operation. One of the functions supported by the API is retrieving temperatures, so that's what I'll focus on in today's tests. The main goal is to prove that this skill works. If you watch the episode about tools, you'll easily recognize the tool calls. Yep, these are the tools from the skill toolset. Ultimately, I got an error related to the missing Code Executor. It's one of the features of skills that they can contain scripts. This problem can be addressed in various ways. But before I move on to the solution, let's look at the session's technical data, the prompts, and the tools the agent offers. It's interesting how the system prompt is constructed. There's a detailed section here about how skills should be used. The ADK automatically includes this information whenever the agent uses any functionality related to agent skills. Next is the section that you already know well from the previous episode. As you can guess, this is the tool set I defined. At the beginning, you can see the list_skills function, which provides the names and descriptions of all the skills available to the agent. Load skill allows the model to load the content of the selected skill. Load skill resource is used to load additional files from the skills subfolders. And finally, here you have the runSkill script function, which in my case didn't work due to the lack of a code executor. Let's take a moment to look at the sequence of events. The model asked for a list of skills. It received a list containing the SmartHome skill. Then it asked to load it. According to the design, the next step was to load the API documentation. This allowed for a request to run a script, which, as you know, ended in failure. Like I mentioned earlier, there are a few different ways to tackle this problem. First, I'll show you a workaround that lets you bypass running the script, so you won't need a code executor. My idea is to add an additional tool to the toolset that allows making API queries. Not as a script, but as a Python function. Of course, this function also needs to be defined. However, it's not particularly difficult and simply mirrors that very simple bash script for calling the API. As I explained in the previous episode, the docstring is very important as it specifies what a given tool does and how it should be called. This function, which is part of the toolset, won't be available to the agent right from the start. It will only become accessible once the skill is loaded. Otherwise, such a function provided to the agent completely without context could generate only unnecessary confusion. The function is almost ready. I just need to implement error handling. The URL lib is underlined because it is not recognized. I need to import at least request. Now this is fine. The remaining part is assigning the new tool to the SmartHome skill. You can do this by going into the SKILL.md file and updating the metadata. This part is specific to ADK. I am adding the ADK additional tools header along with a list of tools, which in this case contains only one item. It might be a good idea to tweak the description since it mentions the script, but I'm confident that Gemini will manage this situation just fine. Let's go back to the agent for a moment and see if everything is all right. Let me maybe move the toolset definition below the function code. Now everything looks perfect, and I think I can check whether the agent can handle this situation. I'm starting ADK Web. Once again, I'm asking for the temperatures. For now, everything looks very similar when it comes to handling the skill. However, here we have a difference. An additional tool is being called. And finally, I got the result. So the agent managed it by using the additional tool. It's also worth confirming that this additional tool wasn't available from the very beginning, but only after loading the skill. List skills. Load skill. Load skill resource. Run skill script. And nothing else. So at the beginning, that additional tool wasn't available to the agent yet. The skill was loaded a little later. Then the API documentation was loaded. Lastly, Gemini chose to use the extra tool instead of a script, which allowed it to answer the question. Let's also see how calling this tool is visible in the session data. Call SmartHome API tool. Here is the invocation of this tool. Here is the response received from the API, what was ultimately translated into the result. But this is just a workaround for not having access to scripts. You can also choose to trust the scripts and run them. Let me show you how. First, I'm undoing all the changes I made to add the extra tool. Okay, I returned to the previous version. Now I'll import the Executor class. If something has unsafe in its name, it should make you think, right? It is definitely an important issue. However, much depends on where those skills come from. Did you create them yourself and trust the scripts, or were they downloaded from the internet? In this case, I know the contents of the script, so I have no problem running it locally on my computer. However, it's important to know that there are various other options that allow you to execute code in different sandboxes. For now, I'm proceeding with unsafe local code executor. I assigned the code executor in the skill toolset definition, and that should be enough for the agent to be able to execute the code. Let's test it. This time, I'm asking about the temperature outside. So far, everything is moving forward quite similarly. Oh, there's run skill script. Successful. And there is also a final correct answer. Let's see it once again, step by step. The list of available skills. Of course, there is only one, but we have a name and description for discoverability. Based on that, Gemini asked to load the SmartHome skill. In response, it receives the full content of the skill defined in SKILL.md. Next, Gemini asks about the file with the API documentation and receives that. Finally, based on this, the script is run with the API temperatures parameter, allowing it to deliver the final answer. So, I can say that this time everything worked correctly and no errors occurred. I want to show you one more thing today. A second way to define skills. You don't have to load them from files. You can actually define them directly in the code. I'm importing models from skills, and now I want to define a fake skill for generating random numbers. As you'll see in a moment, it's structured much like defining skills in files, just a code equivalent. Here, I define the same thing as in the skill.md file header, that is metadata that enables discoverability. Now it's time for the main content of the skill, so the rest of the skill.md file. Here I use a reference to the random.txt file to show that it still works, like with real files. Here's something interesting. I can easily define the contents of files in the virtual directories. In the file that's meant to hold a random number, I've put the number 7. So every time I ask the agent for a random number, it'll always return 7. The last thing that remains is to inform the agent about the new skill so that it can use it, and then I can test if it works. As always, ADK Web. I'm asking the agent to provide a random number. This time there are already 2 skills on the list. The agent definitely loaded the correct skill. Next, it loaded a random txt as planned. The content includes 7, so the agent's final answer is 7. Obviously, defining skills in code like this doesn't make much sense, but it's an effective pattern to load skills from a database or any other source. Of course, relying on files and the agent skill standard doesn't have to be your choice. You can also prepare your own implementation of skills. The most important thing here is the idea of discoverability and providing the agent with knowledge and procedures when it needs them. An intriguing topic is how an agent can develop new skills on its own, or remember a completed task as a skill to make it easier to repeat in the future. This leads us to the concept of a learning or self-developing agent. But that's a topic for another episode. However, if you explore my channel, you'll find another implementation of this idea there. It's time to finish the episode. May your agents always use their skills correctly and execute scripts safely. See you next time.